How magnesium silicate saves marine life. This is the project that we have prepared. While looking for topics related to environment, we found a recent study that showed that the acidity in seas continues to increase in alarming rate. By searching a little further, we found out that a salt, magnesium silicate, can be used to balance the pH of seas. Since the Industrial Revolution, the levels of carbon dioxide have continued to increase and show no sign of slowing down. This is directly related to the decrease of pH of seas, making them more acidic. This increased acidity makes the environment non-livable for its organisms and thus can cause them to die, break food chains, and in more extreme cases, these organisms can even go extinct.
So, to make this salt, first of all we need to make sodium silicate, and from that we can make the magnesium silicate. So we made sodium silicate by heating 9.5 grams of sodium hydroxide in 107.5 milliliters of water. Once the sodium hydroxide was fully dissolved, we slowly added the silicate and heated the solution in between additions. The end product should look like a clear slime. After making the sodium silicate, we went on with the making of magnesium silicate. First, we have prepared magnesium chloride by combining 2 grams of magnesium hydroxide, 10 milliliters of hydrochloric acid, and 10 milliliters of water. After that, we have heated 31.1 grams of sodium silicate with 40 milliliters of water and then slowly added 8.8 grams of magnesium nitrate that we have previously combined with 6 milliliters of water. After both compounds have combined, we then gradually have added magnesium chloride. In the end, the solution became transparent and a white precipitate was formed. That precipitate was magnesium silicate. So if we had to do it all over again, we would crush the silicate beads more finely, and even though we did a lot of trials, we would repeat the experiment more times, so the result would be near perfect.
So, we found out that the seawater in our country, Albania, has a pH of 6. After we added 0.01 grams in 5 decimeters cube of seawater, the pH became 7. But if we added 0.02 grams in the same amount of water, the pH became 8. Both of these concentrations are suitable for marine life. We believe that in the future, this will still continue to be a problem, because even after balancing the pH of the water, the levels of carbon dioxide will continue to increase, and thus making the water acidic again. Because of this, we think it is more suitable to distribute the salt annually, and the main tasks to do first are to distribute the salt in seas, lakes, and rivers.
The most interesting thing that we learned is that this salt has the opportunity to absorb biodiesel because it contains silicate in it. The salt also serves as food for the fish when it has finished balancing the ocean, absorbing the biodiesels, and precipitating at the bottom of the ocean. We found out that magnesium silicate is present in baby powder, and that shows how good of an absorbent it is. Another alternative, but rather more dangerous, of magnesium silicate is olivine that is found in the nature. It neutralizes the pH of the ocean, but it is a lot more dangerous for the sea life. This is all about this amazing salt that can save the ocean.
We gathered information for our project in different sites such as drugs.com to search for magnesium silicate. Then we searched for understanding the science of ocean and coastal acidification in the United Science Review Maritime Protection, written by Alice Kane. Then we found adding rocks to oceans that could deacidify water and save corals. We then searched for toxic waste from biodiesel production industries and its utilization. And that's all. We hope you liked our project and even maybe learned something new from it. Thank you.